I'm Anil Kumar sharing with you a multiple choice test question on integrating or finding area under the curve for a piecewise function. The question here is f of x equals to x squared divided by absolute x when x is not equal to 0 and equals to 0 for x equals to 0. You need to evaluate integral from minus 2 to 4 fx dx. Now that, as must remind you, is area under this curve, in this curve, between minus 2 to 4. You can always pause the video, answer the question. 5 choices are given to you. Now, to answer such questions, we should rewrite the function as a piecewise function whenever you have absolute x. As you know, absolute x value is equals to plus x when x is greater than or equal to 0 and minus x when x is less than 0. So when we are saying that this function is equals to x squared divided by absolute x for x not equal to 0, that means we could rewrite this as the function f of x equals to x squared divided by minus x when x is less than 0, right? At 0 we are given this is 0 when x is equals to 0, and that should be equals to x squared plus x divided by plus x for x greater than 0. Perfect. So that becomes a piecewise function for the same, right? Now x squared divided by minus x, we could simplify and rewrite this as equal to x squared divided by minus x is just minus x. So we get minus x when x is less than 0. It is 0 for x is equal to 0 and is equals to plus x for x greater than 0, right? So that is how you can really define this. Now it is simple to integrate and get the result. So we have to integrate from interval minus 2 to 4. You can see when it is less than 0, it has a value. So we could integrate it in 3 parts, from minus 2 to 0, and then from 0 to 4, right? At 0 it is already 0. We could include it in any one of those, okay? So let's integrate this. So we have integral minus 2 to 4 for this function, which is f of x. The dx is equals to, we'll do it from minus 2 to 0. When we're talking about minus 2 to 0, then the integral is minus x, right? So it is minus x d of x plus integral 0 to 4, and that time it is x d of x, right? Now integral will be x squared divided by 2 minus sign, so we have minus half x squared, where the x value changes from minus 2 to 0, plus for this one it is half x squared, where x value changes from 0 to 4. Correct? So this is, when I take away, I get minus when I substitute 0, I get 0, right? And minus when I substitute 2, minus 2 here, then minus of this value, which is minus half, makes it plus, right? Minus of minus makes it plus, and this value you get half of 2 square, and over here we get plus half of 4 square minus 0, right? That's what you get. So if you simplify this, what do you get? Let me write here. Half of 2 square is 2, plus 16 square half is 8, so you get 8 here. When you add them up, you get 10. And therefore the choice D is the right choice. So that is how you could actually integrate and solve this question. This question could have been asked in a different way. Those of you who have not done integration, for them it could have been as area under the curve. So right, so it's all very important for even those who haven't done integration so far. I mean, area under curve from -2 to this. As you can see, the function here is minus x when x is less than 0. So it's kind of let me make a hole here first, right? So let me make a hole here, and this minus x means kind of like this. Sorry, kind of like this here, minus x, and when it is greater than 0, it is kind of like this, right? So it's an absolute function with filled in hole because we defined at 0 the values. Let me just fill this up. So it is a continuous function. It is absolute function, as you can see very clearly. And area under the curve which we're talking about, let's say this is -2, right? So this is -2. So we're talking about this area to 4, right? So kind of like this, where this point is -2 for us, and that is 4 for us. So that's the area. So this could have been also framed as area function, right? For those who haven't done integrals. So I think it's very important for all of you. I'm Anil Kumar. I hope you appreciate it. You can always share and subscribe my videos, and feel free to post questions. Thank you and all the best.